Nanotube is a hot topic in the world of nanotechnology. Let's start by analyzing the word nanotube. Nano comes from the Greek for dwarf and is a prefix, means 10 to the minus 9, and tube is a cylinder. So, carbon nanotube is a very tiny cylinder compound of carbon atom. If we look at the middle of a pencil, we will see graphite. Graphite is made of layers of carbon atoms disposed like that. If we take one of these layers, we can roll it up to obtain a structure of carbon nanotube. If we take this layer, we can roll it in this direction, then we obtain a tube with a circumference of its exact shape. If we take a smaller tube, it also has a circumference equals to its exact shape, because we roll it in the same direction. But if we roll the layer in another direction, likely, we choose a direction looking like an armchair. So, the tube has an armchair shape along the sequencement. It can be rolled in any direction, and that defines the final shape and the size of the tube. The way you roll the tube is important, because this determines its electrical properties. Another important characteristic of the tubes is how many layers they have. Until now, we just talked about one layer. This is called single-wallet nanotube. But there are also tubes with two layers, called double-wallet nanotubes, three layers, third wallet nanotube, and multi-layers, called multi-wallet nanotubes. In any case, all of them consist of concentric cylinders. All these rolling up graphite layers were just a representation. Nanotubes do not form by rolling up graphite layers in reality. Let's go with Fred to see how they are produced in industry. Fred, do you hear me?
Yes, Jamie, here I am. Jamie explained to you what is a carbon nanotube, but are they really made? If you follow me in this room, you could probably find an answer. Come in.
There are three main ways to produce carbon nanotubes: arc discharge, laser ablation, and chemical vapor deposition, CVD. Sumio Lijima discovered carbon nanotubes by using an arc evaporation apparatus. With this technique, nanotubes are formed in the carbon suit of a graphite electrodes during an arc discharge by using a very high current. During this process, the carbon contained in the negative electrode sublimates because of the high discharge temperature, and it produces both single and multi-wall nanotubes. Laser ablation is almost the same kind of process as the arc discharge method. A pulsed laser vaporized a graphite target in high temperature reactor while an inert gas is bled into the chamber. With chemical vapor deposition, the growth process involves heating a catalyst material to medium temperature in a tube furnace and flowing an hydrocarbon gas through the tube reactor for a period of time.
The carbon nanotubes has mechanical, electrical and thermal properties. Carbon nanotube is the strongest and stiffest material yet discovered in terms of tensile strength and elastic modulus. This strength results the covalent sp2 bonds formed between the individual carbon atoms. Because so many different varieties of carbon nanotubes exist, we cannot generalize the electrical properties. In theory, it shows that carbon nanotubes have a great ability to conduct electricity. All nanotubes are expected to be very good thermal conductors along the tubes, but good insulators laterally to the tube axis. Due to those properties, carbon nanotubes have many applications for today and tomorrow. Two of those applications are thermosil and hyposil. The first one provides thermal protection on any substrates. The other allows to reduce the weight for lighter fiber reinforced composite materials used in aerospace, automotive, marine and sports applications. A future application would be the cable for the space elevator, because it needs to be strong and to conduct electricity to supply the space station.